My name is Héctor RODRÍguEZ. I'm a media artist and film scholar, and all of my work is about the interaction between computer vision and film history. Many of my recent works have been about the concept of a visual dictionary. So this is an idea that's very important in many machine learning applications. But I take this idea and I make it the focus of my artistic exploration. Suppose we select two different films in digital form. Then we choose one single image from the second film and allow every frame in the first to project a shadow onto this fixed image. As the frames in this first film change brightness, the fixed image becomes correspondingly lighter or darker. So this image, in a way, becomes a compressed version of the other movie. Instead of fixing only one image, we can select a set of frames from the second movie and allow every frame in the first movie to cast a shadow on each of them. The first movie is in this way decomposed into various shadows. The superposition of all these shadows then gives an approximate reconstruction of the original frames in the first film. We can consider the fixed system of images as a visual dictionary. If the number of images in the dictionary is increased, the reconstruction of the original frame will also become increasingly more accurate. This idea can be exhibited as a work of art in several ways. In one setup, every frame in director Jean-Luc Godard's classic sci-fi film Alphaville is decomposed using not one but 4 different visual dictionaries. These dictionaries here consist of images selected from that same film. In other versions of this work, unsupervised machine learning algorithms are used to select archetypal images to serve as dictionary elements. I have explored the same idea of decomposing and reconstructing movie images in other works. In a project called Z, for instance, a system of disks invented by physicist Fritz Zernicka is used to represent cinematic rhythm. These disks can decompose movement and light. If the images in a source movie become darker, the circles also become darker. If the shapes in the original movie change rapidly, the circles rotate faster. A work of cinema, like a piece of music, has its own rhythmic form, which can be visualized by means of the changing disks. Different disks in the system respond to different visual frequencies in the movie. A more recent development of this research project focuses more specifically on movement. The project is entitled Errand, the kinetic propensity of images. In this project, moving sequences are decomposed using a dictionary of fundamental motion patterns. A machine learning algorithm creates a dictionary of elementary movements for each shot, and then decomposes the optical flow vectors of each frame in the shot using that dictionary. Every elementary movement in the dictionary represents one component in the original optical flow, such as a direction, for instance horizontal or vertical, or a motion pattern, for instance centrifugal or centripetal. The algorithm then reconstructs the global motion of the shot by combining the various latent components. The visualization employs a technique from fluid dynamics known as streak lines. This project uses movie material from the great Chinese film director King Hu, whose action sequences highlight the rhythmic properties of human motion. All my projects can be seen from 2 perspectives, either as artworks or as tools for the analysis of films. In my future work, I plan to extend many of the tools I have created in order to allow for the comparison of films from different traditions and for the analysis of those films, in order to deepen our sensitivity to film as an art of rhythm, motion, duration.